We're here today to introduce and explore Rhino inside Revit. My name is David Spergel from Microsol Resources. I'm joined today by our marketing director, Annalisa Montenegro, and our marketing manager, Brenda Araujo. So we're also extremely happy to have a special guest today, Japhy Walton from McNeel, who are the developers of Rhino. He will be assisting with some awesome demonstrations. So here's a little agenda for today's presentation. As Youngjin mentioned at the top of the session, we are recording today's presentation, and it will be shared with all of you afterwards for your continued enjoyment. For AIA credits, please reach out to marketing@microsolresources.com. I think that'll be posted in the chat as well, so you can reach out to us for those AIA credits. And like I mentioned, if you have any questions, please don't hesitate to type them into the questions panel. We will get to them at the last portion of the session. So a little bit about Microsol Resources and our relationship with McNeel. We are a partner and reseller of Rhino software. We offer the software, technical support, and training. We help our clients with onboarding, technical support, and access to free webinars and content like we have today. In addition to being a McNeel partner, we're also a premier Autodesk partner of over 35 years and a Bluebeam Platinum partner. We work with the best of design and construction technology solutions, and we've curated this suite of software applications for our clients. If you have any questions about any of the solutions listed here, please don't hesitate to reach out to info@microsolresources.com. So we don't just offer the software, we help you get the most out of it. Software is a big investment these days, and we're here to make sure that you get the most out of that investment. So from implementation to training and ongoing support, we provide comprehensive services to ensure your technology works seamlessly with your workflows. So just a quick overview of the services we offer: implementation services to set up and configure your software tools, training and support, custom solutions, whether it be tailored workflows, reports, or dashboards with the information for your specific project needs, as well as project audits and optimization, reviewing and optimizing your current projects for efficiency and cost savings. And then a little bit of a preview of some upcoming events. On January 28th, we are hosting Tech in Transition, Streamlined Project Tech Shifts with Autodesk Construction, hosted by our very own Danielle Lucas, who is our Director of Construction Solutions. She will dive into real-world strategies for adopting new tech platforms without disrupting active work, ensuring your team stays on track and aligned. So stay tuned for that one. That's in just 2 weeks from today. And then as well, another BSA event that we are happy to be part of on April 8th. We will be presenting best practices for design collaboration in Revit 2025, exploring the Bridge tool. Join us as we showcase how to streamline, enhance collaboration, and improve data exchange between teams in Revit 2025 and across projects with the Bridge tool. And like Youngjin mentioned, we are recording today's webinar. Again, it will be posted up after the presentation for your future enjoyment. We will be sharing the video, and we'll also be on our website under Tech Resources, so you can watch it again or share it with your colleagues. So now for the fun stuff. Today, we will be exploring Rhino inside Revit. My name is David Spergel. I am an application specialist here at Microsol Resources. I got my degree in engineering right here, or I should say right there. I'm in New Jersey, but right here at Boston University. And I am a certified Rhino and Bluebeam instructor. Joining me from McNeel is Japhy Walton. He's an application specialist from McNeel, and his background is in architecture and fabrication. So here's just a little agenda for today's presentation. I'll start by introducing exactly what is Rhino inside Revit and what made it possible. Then I'll show you a few of the basic interactions that this technology allows you to do. And then afterwards, I will hand it off to Japhy Walton from McNeel, who will show off some of the more advanced workflow capabilities. Finally, we will open the floor to answer any questions that have come up. All right. To set the stage, we have two very powerful programs, Revit and Rhino, each with their own relative strengths, right? Revit is very powerful in the field of documentation. Rhino has a very powerful geometry engine, which makes it an extremely popular choice for conceptual design. But once the 3D model is built, what Revit does, Revit lets you create as many views as needed, places them on sheets. Revit's very powerful at organization and documentation. Rhino has a very powerful and flexible geometry engine, which, again, like I said, makes it a very popular choice for conceptual design. You don't have some of the limitations that you have when you're working with geometry in Revit. Consequently, each program has their own visual programming interface, right? Revit has Dynamo, Rhino has Grasshopper. And these allow users to develop scripts in a visual environment rather than directly in a programming language like Python or C#, which really opens up these programming elements to a lot of users that may have been may have avoided programming in the past. So in addition to those plugins, there are various other plugins or add-ins that can be installed for each program, extending the capabilities for the base program. There are some plugins that are available for both, but generally these exist in different ecosystems. You can see I highlighted, these kind of go back and forth, but not really. They just work in both. When transferring a design from Rhino to Revit, the workflow usually involves importing a 3DM into Revit, 3DM being the Rhino native file type. However, it will come in as a generic model. It will not be categorized properly, won't section as native Revit walls and floors would. So the workflow requires a lot of wall by face commands, and generally just a lot of rework is necessary to make the two play nice together. Until now. So with the introduction of Rhino 7, I know we're on Rhino 8 now, but Rhino inside Revit was introduced in Rhino 7. And so with the release of Rhino 7, the program, the Rhino.exe program, was rebuilt into a DLL, or a dynamic link library. As a result, Rhino 7 was leaner, and it can run inside the memory space of other .NET applications. Now, this is important because in this case, it allows the full Rhino 7 application to run as an add-in or plugin for Revit. So this is incredibly powerful because this provides full access to Rhino's geometry engine, Grasshopper, all of the new features for Rhino 7 and now consequently Rhino 8, and all plugins that work with Rhino 7 and 8, all from within the Revit program, right? Oh, look at that. So some of the new features introduced in Rhino 7 include sub-D modeling, quad remesh, clash detection, and many more. So these tools now can all be accessed from within Revit. So now your plugins have plugins, which ultimately gives you more plugins and more power and flexibility as a designer. So what I mean by that is if you have plugins in Grasshopper, right? Plugins like Kangaroo, like Pufferfish, like Elephant, like Karamba. These plugins that are designed in Grasshopper can now be run inside Revit by running Rhino inside Revit. So Rhino inside Revit acts as the bridge between Revit and Rhino and can access all APIs between the two concurrently, allowing for the transfer of data and geometry between the two programs. Revit seems to be the most widely adopted and called for integration of Rhino inside, but there are also capabilities to run Rhino inside AutoCAD, Unity, and other console applications. So really extremely powerful new development. So just to start, once you install, this is like a little bit of baseline stuff, but once you install Rhino inside Revit, you'll notice that you get like another little tab on your Revit interface called Rhino Inside. This contains the Rhino inside Revit. And so you can start it by clicking the Start button in this tab. The add-on then attempts to load Rhino inside Revit's memory and make sure everything is licensed and good to go. Once the load process is completed, the new Rhinoceros and Grasshopper panels will be added to the toolbar. So this is what it'll look like here once you hit that Start button. So you push this Rhino button. This will open a Rhino window that is running inside Revit's memory space. This is different than the desktop application of Rhino, only in the sense that this is the one that's connected to Revit. Running a regular Rhino window, not through Rhino inside Revit, will result in just a regular Rhino instance that is not connected to Revit. And same goes for clicking this Grasshopper button. Clicking Grasshopper will open up the Grasshopper interface through Rhino inside Revit. So when you're working with Rhino inside Revit, you'll always want to be working through this tab here to make sure that everything stays together. All right. And once you're in Grasshopper, there are Revit-aware component icons that help identifying the action that the component performs. So as shown in this little diagram, the base color shows the type of action. For example, lime green for query, pink for deconstructing and analyzing, orange for modifications, and then turquoise for constructing and creating, red for deleting, and blue for parameters. So there are a series of badges applied to icons as well that show type, identity, or other aspects of the data that the component is designed to work with. So this is just a neat little cheat sheet, and you can see that reflected here. You can see the different colors of the different elements or different components over here. All right, so this is arguably one of the most important features of Rhino inside Revit, which is Grasshopper. Like I said, it's opened by clicking the Grasshopper button in the new Rhinoceros tab in Revit. And note the extra Revit tab, denoted here by R, in the Grasshopper window, which contains many Revit-aware components. This is important because if you just open a regular Grasshopper window, not within Rhino inside Revit, you will not have access to these components. But when you do open Grasshopper through Rhino inside Revit, you do get access to these Revit-aware components. So again, that's why I said it's important that if you're working with Rhino inside Revit to, work with Rhino inside Revit, not the regular instance of the Rhino application. There's also the Revit primitives panel, accessible through the default parameters tab. So just that's accessible there. All right, and a few quick base level examples, one of which extracting Revit geometry. So let's create a simple definition in Grasshopper to extract the geometry of a Revit element. Grasshopper is by far one of the most exciting add-ons for Rhino, and as part of the Rhino inside Revit project, has the potential to improve the design and documentation in Revit dramatically. So we open a simple Revit model, draw a single wall right there. And then from the parameters panel, for the parameters tab, go to the Revit primitives panel. We're adding a graphical element parameter. All right, so that'll add this little node over here into our Grasshopper interface. And what we'll do is we right click on that component and click on set one Revit graphical element. Grasshopper will then switch to the Revit window, and it'll ask you to select the Revit element that you want to reference. So we select that single wall element we created earlier. Okay, so now we drop a panel component into the definition, and we connect it by clicking and dragging from the primitive component to the panel. And then you can see that the parameter now contains the selected wall elements. So the panel is essentially a readout of this component. We had selected the Revit wall previously, and then it shows up here as wall 1. Let's grab the wall geometry by using a Revit specific component. So from the Revit tab, we go to elements, and then we add an element geometry component, which will get the geometry of the specified element, as it says in that description there. Little tip is that if you I'm sure you know this, but if you hover over any of the items in Grasshopper, it'll give you a brief description of what that component does, which is pretty helpful. So after passing the graphical element output to the input of the element geometry, the new Revit specific component extracts the wall geometry from the wall element using the Revit API. So this geometry is then converted to Rhino BREPs, since other Grasshopper components might not be familiar with Revit geometry. So it can be passed to other Grasshopper components for further processing. So you can see we added another panel component here as well, just to show you what that geometry element or that geometry component is, and it comes in as a closed BREP. All right, and then we can see that reflected in our Rhino interface there. So similar to other Grasshopper geometric components, output geometry is shown as a preview in both Revit and Rhino viewports. So very basic example, but as you've seen, working with Rhino inside Revit is very intuitive and somewhat simple. Well, I say somewhat because you gotta. It's still programming, so you still got to know what you're doing, but it's very intuitive and pretty straightforward. The Revit specific Grasshopper components are one of the most important aspects of the Rhino inside Revit project. Grasshopper script components like Python and C# can also be used to access Rhino or Revit APIs simultaneously and create custom components in Grasshopper for your specific workflows. So we just saw an example of converting Revit geometry into Rhino using custom Revit components in Grasshopper. Grasshopper has many other Revit-specific components. A subset of these components allow the user to create new content inside the Revit document. So we just did Revit to Rhino. Now we'll do a little bit of Rhino to Revit. So we'll create a simple wall in Revit using a few of these components. So to create a wall in Revit, what do we need? We need a line. That's the basis of the wall, which it defines the start, the end point. We need the type of wall. We need to tell Revit what type of wall it is. We need a level to host the new wall. And we also need the height of the wall. So opening Rhino inside Revit, of course, we draw a simple line from the origin of the document. Now we open Grasshopper inside Revit and add a curve component from the geometry section. So we right-click the component and we select the newly created line in Rhino. So just like we did before when we did the Revit geometry, we enter this, we right-click on it, and we select the Rhino geometry. In this case, it was the line that we just created. Okay, next, from the Revit input panel, we'll add the following components. The built-in categories picker, the element type picker, and the document levels picker as well. So we'll add all of those components to our Grasshopper definition. And finally, we'll add a Grasshopper integer slider as well, which we'll use to provide a height for our new wall. All right, so to create the wall, we're going to use a Grasshopper node that can create a Revit wall by curve. So from the Revit build panel, see from over here in wall, we'll go to add wall, right? And the description says, given a curve, adds a wall element to the active Revit document. All right, so now that all of our components are added, our Grasshopper definition will look something like this. And let's organize them before we connect all of the parameters together. From the list of categories shown on the built-in categories component, which is this guy right here, we'll select the walls category. And we'll connect the output of that built-in categories to the element type picker, which is this blank one over here. The input parameter is not visible by default, but if you just drag it over, it'll connect. So once that's connected, it will now show a list of wall types collected from the model. So this is in real time accessing the Revit document to pull the categories and the element types from the model. So if it's in the model, it will show up in here as a selectable option. So we connect all of our other components as shown. The curve geometry component connecting to the curve input of the wall component, the level selector component connecting to the level input of the wall component, and the height slider connecting to the height input as well. And then the wall geometry output, or the wall output, being connected to the geometry component. Okay, so the add wall component now has all of the information to create a new wall in Revit, which we see right here. And then the same wall geometry is also visible in Rhino. So once it's everything is connected, you see the preview here in Rhino as well as the output in Revit as well. And then on the next slide, we'll see as we slide the integer slider up and down, it's passing a height value to this component, and then it's adjusting in real time. So again, very pretty basic example, but I think this is a great way to see what is possible with Rhino inside Revit. So before I hand things over to Japhy to show you some of the like real cool stuff, here are some things to consider when building your Grasshopper scripts. And this applies to any Grasshopper script, but um, you know, but also for Rhino inside Revit. So when you build a Grasshopper script, you want to consider the entire workflow. One very common one, as we just discussed, was doing design work in Rhino and then implementation and documentation in Revit. Okay. So it always helps to start with the end goal in mind. Work backwards from the inputs. What do we need to communicate in Revit? Categories, elements, materials, levels, etc. And what do we need from the Rhino and Grasshopper side? Extract projections, front, back, left, right, clean and prepare geometry, simplify, removing short line segments, etc. So really, just you want to think of the entire process, the entire workflow before you go out and start designing your Grasshopper scripts. And with that, I will hand things over to Japhy, who will show you some of the real cool stuff that you can do with Rhino inside Revit.
Thank you, David. That was a great intro. Showed a lot of the essentials. I'm going to share my screen here. So I'm going to go a little different. The goal of this is just kind of show you a few different workflows, how you could use Rhino inside Revit. On this one, I'm going to set the stage. This is an apartment building. We're looking at, we'll say like a conceptual design phase, where we're gonna do a tensile structure over this canopy, kind of a canopy. So what you use Rhino and Revit is really going to depend on your workflow. We're going to show this as kind of a conceptual design, but it could be you could be a structural engineer, you could be a fabricator making the little panels afterwards. So depending on what you're doing, sometimes you're going to be going from Rhino to Revit. In this case, we're going to be just pretty much using Grasshopper to generate Revit geometry. Other cases, you're going to go from Revit to Rhino, maybe the fabricator or the doing some sort of analysis. So one aspect that I'll add on to in the options, you can actually have Rhino start up right when you're starting up Revit, so you don't have to push the button. Adds a little bit of time like any add-on, but there's a couple options like keeping the UI on top, as well as getting the latest build. So you can get the kind of stable release that's once a month, the release candidate, which is like once a week. It's going to have a lot of the new stuff. And then the daily build, which I'm running right now, so you never know what's going to happen. It's a big challenge doing a live demo with Rhino inside Revit because I've got my screen kind of resolution shrunk down. I'm using one monitor for everybody can see and it presents well, but it makes kind of you'll see I'll be moving windows around just so we can kind of look to see what's going on. So I'm going to fire up Grasshopper. So units is very important. So you want to have your Rhino matching your Revit. So Revit is default in decimal feet. So it's asking me what my Rhino units need to be. So I'm going to use feet. I'm going to just drag and drop my my canopy. And like David mentioned, we're just kind of gonna go through the inputs and outputs. Like I said, we're going to attach to these structural members that are in the roof. In this case, the input is going to be those members. So we're querying a Revit type, then getting the parameters from that type. So then in this case, we could kind of set that elevation right there. From there, we're gathering some data to make a surface, and I suppose I should probably get my viewport open in Rhino. Like I said, I gotta always kind of be moving my windows around so you can kind of see what's going on. Typical grasshopper demo. So in this case, I'm not going to go too deep into it, but this is where either you visually are creating your design, maybe have some structural input of like the spacing on these supports, the height of this of the kind of the arch, and from there, so we could we could be moving stuff around. And this is using one of our default plugins of Kangaroo. So that's a solver that people use to do kind of motion simulations and energy simulations. It's quite extensive, where you can put on your goals and everything like that. So once you're happy with this point, I'm going to take it to the next level where we're creating a tri-mesh. So we're kind of creating it. We're panelization of, in this case, we're going to do triangles because they're planar. They're a little easier to manufacture. This could be anything though, but and we're colorizing them per size. So they're optimized by the Kangaroo for a certain length, but that it's only going into a certain amount of optimization. This way, the fabricator, each color is just a unique size. So the fabricator might say, okay, just kind of keep it under 10 different sizes, and it's not going to be any additional setup cost to manufacture. We would then start looking at bringing this into Revit. So here I'm using Rhino 8. I created a material out of that color. We're going to go ahead and send that as a direct shape. So I don't know if you're probably familiar with direct shapes from when using IFC files. Right. But it's not a real family. It's kind of a quasi family. It's really nice that you can you could put on parameters, you could put information, you could generate schedules from those direct shapes, but they're not editable families. So we have so they do have some drawbacks, but they are great for getting an initial design or concept in, or for like a fabricator going from Rhino into Revit, and they're not going to build a bunch of families. They just want to put the geometry in for coordination, in a sense. So there we had our canopy with our sizes. I'm not going to kind of flex it because there's about, I think, 1,500 different panels, but it kind of gives you an idea of how you can use plugins such as Kangaroo to optimize to get your initial concept in. Another way to do these panels would be with an adaptive family. Some of you may be familiar with that. So now I'm going to show an example. So here is the adaptive family. If you're familiar, you could create these placement points for the adaptive components. So we did a 1, 2, 3, 4, and then they also have a shape handle point. We're able to that aren't placement points, but we still have control of those. So let's get our Rhino going. Already had it open. Need to move my thing here. So here, I just threw some points down for the demonstration. I named them kind of in that order, the 0, 1, 2, 3, 4, 5, similar to how that adaptive family was set up. Also, I have my preview on. There we go. And now I've disabled my adaptive component. There we go. Well, maybe I ran into an issue. It worked earlier.
The curse of the live demo, right, Jeff?
Yeah. And this wasn't even the actual demo part of it. I have no idea. Anyways, I'll go into the next phase of this. I was just gonna show how that worked with the adaptive family, but a more computational design one. I'm gonna open this file, and then open my other one. Go. Like I said, it's always fun getting moving these windows around.
That's the hardest part of these webinars, right? Is the window management.
Yep. So here we have a more complex demo that's actually working. So here I've created a grid where I could, so once again, the kind of inputs and outputs. I'm going to actually make this a little tinier, so we have a little more reactivity. But essentially, we're gathering the points. So once again, we needed 6 points. So my initial grid gave me the 4, and then we kind of doing a little fun stuff here where we're scaling these in to kind of create those other 2 points that eventually are going to create our adaptive component. The one part I wanted to show was the element dependence component. So this gives me the order of the points. So that's how I could kind of figure out which points I need to ensure that I have a proper order going on. So I have there we go. So 0, 1, 2, 3, 4, 5. That's going to match my adaptive component. There we go. And that's firing into Revit. This one also had some material parameters. So we're querying those materials and setting the materials to these colors. And in this definition, I was to do something a little more fun with the design. We set it to do a kind of a reaction to this closest point on curve. So as we move this around, you can see that's affecting our opening size on our adaptive components. I really wish that other one was working, but because you can actually do this, like this adaptive component could be laid flat here and be the base for doing like to use face hosted Revit, like doing curtain walls and stuff. This could be, you can do the adaptive component. So your Revit, your Rhino points are going to, your Rhino points are going to be driving your overall building design, for instance, or something like that. All right. So the next one, doing a little different. So this one's going to be about this family right here. So this is kind of an RFI box. It's kind of a neat family that has some 3D text that we can drive from Grasshopper as well. If we have a little time, I could dig into it, but I think I only have about 5 or 6 more minutes, so I'll keep moving. So on the RFI box, inputs and outputs. What I'm doing here now, this is getting, it's a little spaghettified, as we say when we get kind of a lot of wires going around in a Grasshopper definition. Now that we're in Rhino 8, we have a lot more components to help. You can break up your Grasshopper files, so it's like you can do one part in one file, one part in the next. Similar how you could do in Rhino 7 with Elefront. You can now, it's a great workflow that keeps you from getting absolutely monstrous definitions that are hard for other people to work in. So
Kind of like creating functions, right, in other programming languages.
So in this one, what we did was we got the RFI scope box. So that's like you're going around. You could do it as like there's a number of ways to do it. I think on this one there was like some clash detection going on at one point, and then the box would be placed around that clash. Then you label it, and then the idea here is that we're going to generate an RFI from just placing our box, maybe naming it. So this one, we get all our types in a file. We do get all the type instances. We create, say, these blue components, like David mentioned, they're color coded. This is a create component. Once it activates, it'll turn black. Same thing with this setting the element parameter. So I create a detail view, then created a 3D view, setting some like view scales and the section box, and I'm adding sections and whatnot, and then creating a sheet, putting a title on them, and adding the viewport. So one sec, I gotta move my thing. And so I can go to my sheet that we just created. That is our RFI sheet. So it generated one of those for each of the boxes, filled out the RFI, kind of renamed them, put some sections, plans everywhere. Now you could print them out. Everybody could, or put the PDF, take them in the Bluebeam, and start getting your request for information taken care of. So that's kind of a more of a drafting scenario, I guess. There is a lot of components for creating views. So if you go to the view one, you can see here we have ceilings, all our cyan create components, add schedules, floor plans. We actually have access to graphic overrides, so you could do some generative coloring of your manage your crop extents, which is really handy. But that's essentially that one. I'm going to make a quick pass through these just because for people to see them. So there are some dimensions. Dimensions are A little tough to do programmatically, right? Because Revit's requiring a specific face or a point. So if you're going to do that via scripting, you're going to really have to have either a lot of the same thing or a very good way of handling all the outliers. But you can do dimensions and things like that. So architecture, component, lots of direct shape stuff, lots of document information, working with the elements, the Revit objects, filters, super critical because that's essentially like when you make a schedule and you add your schedule and you tell it, oh, I want all generic models, and you create this parameter filter that have the comment of off or whatever. So you should be familiar with a lot of these items. So adding grids, playing with object styles. The one thing, oh yeah, so here's a tensile type structure. We do have our forum and our guide that's going to really, if you have any sort of questions, this is the place to start your investigation. I'm always on the forum. If there's things you need that you really need for your project and something that like a component you might need, this is like you go to the forum, you make a post, and we'll see what we can do. I'll do this last but not least. This is kind of a similar workflow to the adaptive family, but this is actually, these are curtain panels that have parameters and materials already built in. So fire up our grasshopper. Go to we're going to use feet. And one more. So this is a similar sort of thing that we did earlier where we're getting kind of a closest point, and that's that data that we're getting from there is going to drive our Revit family or whatever you're doing. So in this case, it's the closest point to here. This could be information from, say, a lighting or a visibility simulation that you wanted. So like the people over here don't have a view, so you don't have to waste a lot of glass. As you can see, is when we're moving this around, it's modifying those element parameters. So, and you could also control the materials and stuff like that. So that's my quick 20 minutes of look what you could do. The big thing here is, yeah, being able to kind of navigate Grasshopper a little bit. There are simple workflows of just getting geometry back and forth with like the graphical element. At any time, you could place one of those on a canvas, set something, and then bake that right into Rhino. That's really handy for people that are doing like highly detailed parts where the Revit's not as detailed. So you bring it into a section of the building into the Rhino and then create more detailed items and then push those back into Revit for documentation. But I think we'll go to Q&A.
Yeah, thank you for the sharing the awesome and cool the example, Japhy. I really appreciate that. And then during your presentations, we actually got some questions, and then half of them are actually the answer by Annalisa and then David. I really appreciate that. And then we still have the open questions. 2 questions from the Philip. So what is the origin of the import and export element? Does it actually also follow the Revit true north or the project north, something like that? Japhy, do you have the answer?
Yes. So so the element location, the Revit origin is always 0, 0, as is Rhino, but Autodesk products use the shared locations. So we have, let's see, shared locations, so shared sites, as well as shared sites, site locations, and there's a project. Not that one, but essentially,
I think it was project location, right?
yeah, there. Okay. Oh, project location. Thank you.
Yeah.
Location. There we go. So this one, it could take in. Oh, that was dumb. There's a
Sorry.
few. There we go. Yeah. So you. Let me get my display on so you have full names.
Yeah, the things we do for visibility in our own workflows don't always lend themselves to presenting.
Yep. So essentially, you can get your survey points, you can get your project base point, you can get your shared location, because say you have you have like an imported site with a different, where the whole project north is rotated and all that. Essentially, what these are, they'll cast to a plane. They'll cast to a plane if it was on a different, and then you do a orientation that will, so you have a target and a source. So you can move your Rhino geometry to the shared location, or vice versa. It's not optimal because in large sites where they're very far from origin, that's never going to be a good thing. So you want to move your geometry closer to Rhino. There's also a guide on, I think it's Revit to Rhino. Oh, Rhino to Revit. Yeah, this one. Yeah, one of these guides has an example of moving the objects into your site location when you have a shared site. Essentially, that site is just going to be a plane that you use to transform your geometry back and forth. Revit's internal and Rhino's internal are always 0, 0. Hope that helps.
Great. And there's another question from Philip. Can we create the Revit schedules with those panels to create it from the Rhino? I think that this is one of your the example file. Can you create the schedule?
Yep. So I mean, they're going to be shared parameters. This add schedule is actually only adding in the schedule graphic, an already created schedule, onto a sheet. We do not have, because when you create that schedule, there's a lot of little particulars you got to set. There has been a couple people on the forum that have done a scripted component that you could do to create schedules, but we don't have a create schedule component.
It's a lot of case by case kind of stuff, right? So if you can, if you can script from your own workflows and you know the things that you guys use, you can create that script. But I think that's what you mean when you say like it's not like a built-in thing, because there's so many.
Yeah, because you're essentially going to be creating these parameter filters. They're the exact same thing. So if you create a schedule and quantity, yeah, so there's a lot goes into it. You got to either set the category. We'll go to generic. This will only take 2 seconds, I swear. But yeah, so when you're adding a field, available field, so that the amount of available fields are going to be governed by that category that you picked. So as you can see here, when you start to get a lot of different variables that need to be set, is it worth it to do it programmatically, or is it better just to go in here and quickly make your schedule and then use Rhino to place it or whatever? But this is where creating those rules and everything like that is essentially the same. And the same thing as creating a filter here is creating these rules is you can do it, absolutely, but
yeah, I think it's also about using each program to its strengths, right? Being able to set those schedules is one of the strengths that Revit brings to the table, right? So you wouldn't necessarily want to program all of that stuff in Grasshopper when Revit makes it so easy, but then also you know, Grasshopper and Rhino bring a lot to the table that Revit isn't so good at, that you know that we went over in the presentation. So really this, you know, it's about, you know, this isn't about like a Rhino replacing everything in Revit, but you know, using both of the programs to, you know, for what their strong what their strong suits are.
Yeah, I 100% agree with you, David. And then by the way, Japhy, do you have the useful resource and the link to them to share with especially the first time user of the Rhino inside Revit?
absolutely. Yeah, it's all going to start with this getting started page, which I'll copy that to the links, and that gives you links to the Rhino inside Revit plugin. Also, good thing to mention is it'll install in Revit 2020 all the way through 2025, actually. But Rhino 8 is required if you're going to be in Revit 2025 due to the .NET change.
.NET, yeah.
Yep. This is going to be the getting started link. Like I said, we have our guides as well as Discover, where we have some of the people, some workshops, all sorts of information to get you going. Hassan. But yeah, I'll put this link into the chat.
And like you mentioned, the forums, I don't know if I've seen a more active, well, you know, at least in regards to like, you know, design software, I don't think there's a more active forum than the Rhino forums.
Yeah, well, it's the Grasshopper community has been amazing. I mean, Grasshopper started out just as a kind of a simple plugin and hasn't turned into something way more than anybody ever envisioned, David Rutten ever envisioned. And it's all because of these people just that love to learn, like to get into these workflows. That's amazing. And like for me, yeah, I'm trying to know as much about Rhino as possibly can. And then for Revit, I try to maintain and kind of getting deep dive into everything about Revit is, there's so much to Revit. There's so much to Rhino. But having people experts that are going to answer your questions like almost immediately is phenomenal. And it's such a great community.
We do have another question. Youngjin, I'll ask a question if that's okay.
Yeah, David, go ahead.
Drew is asking if we are able to modify the 2D grid extents in a series of views. For instance, sometimes our grids get messed up by someone dragging the 3D extents instead of 2D. It would be crazy if we could fix that easily in Rhino inside.
Yeah. But yeah, you're talking about setting the the 2D grid. I think I'm pretty sure there's so this it's not this one. You're talking about the grids and the levels extents. I'm 99% sure that that workflow has been done on the forum with like a scripted component. but yeah, like,
so you're saying the answer is yes, someone's probably
yeah.
done it and it's on the it's on the forum, and that's the beauty of the forums.
Yeah, and I'm trying to remember. I'll check to make sure that we have a feature request, because that is a really good one, because it's a really big pain. I mean, granted, a lot of people use scope boxes to manage that. And scope, like, we're always going to be limited by the Revit API. So like when David was showing how he added a wall, you put a line in the Revit API, lets you create a wall two ways. You can either do a line, pick 2 points, or you can do a wall by profile. So that's all we can do. That's the Revit API. And the same thing with like a scope box. There isn't an API for creating a new scope box. You can copy other scope boxes. You could set that scope box parameter that's going to control those grids and levels. But yeah, we're always going to be limited by what Revit allows us to do. And it's the same thing with the tolerances as well. Yes, we can do crazy geometry, but bringing it into Revit, it's always going to be subject to that small, like 0.01 of an inch tolerance. And we handle the geometry really well. We'll try to bring it in as native Revit geometry. Then we have a series of import options that will end up in that mesh that you don't want. But we try to bring it in per Revit's geometry rules. If it doesn't use those rules, we'll go to the next little looser version and so on.
Another question in kind of that vein, Daniel's asking, is it good practice to implement geometry into Revit without Grasshopper? So presumably taking Rhino geometry, bringing it into Revit without using Grasshopper, and in such case, where in Rhino do you link the Revit data? Yeah, Japhy's showing off right now that you can directly import a 3DM, which is the native Rhino file, into the active Revit model or family. But as I understand it, that's just a direct import, not a link, which is what we've been showing off with the Grasshopper. Grasshopper is really the connector, right? That links the two together. So you can pull in the geometry through the 3DM import, but it's just an import. If you modify that 3DM geometry, it doesn't get directly reflected in the model. Japhy, correct me if I'm wrong. But Grasshopper is the tool that creates that link.
Yeah, I definitely don't recommend the import 3DM. And I would say 95% of the error reports we get are due to that one, because it doesn't have as much error handling and stuff like that. The best way, like the easiest way, is to use that direct shape, to add direct shape component. This is great for initially, plus it gives great error, like warnings of if there's geometry that's a little funky. It's going to highlight it in Rhino, tell you where it's like, okay, you've got some really tiny small edges. Oh, there's the chat box. All right. The other way, so yeah, it's like kind of initially doing with a direct shape, or ideally if that geometry will come in as a family. So you're going to have so much more control over categories and everything. But these shapes, like, you could just put some geometry in there. It's going to send it right into Revit. You don't need to do a whole big definition just to get a little bit of geometry in. So that's the more, I would say, recommended, at least for if you're not going to create a family.
For sure. I don't know who decided to put that import 3DM button in there, but yeah, I get why it's there. I do. I get why it's there. But yeah,
you didn't.
I didn't make that decision.
Well, and there's actually a neat one, and I don't know if it's in this build. where we hooked up copy and paste.
Oh, that's cool.
Going back, I think it's only Revit to Rhino, and it might not actually be in this build yet. So
yeah, on that note, actually, Rhino.inside Revit is actively being developed. Things are being updated all the time. Like even from when I created my slides to now, components have been added. So really a very active development process. I think we got time for 2 more questions, which is great because we have 2 more questions. Funny. That last example with the facade and the attractor point, what are the elements that are then being modified in Revit? Are they curtain wall elements, or are they generic model elements, or families with type parameters? And how are the materials already applied? I know that was actually like 4 questions, but
on this one,
like when you're moving them around, and it was modifying the elements.
Yep. So these are actually just a quick family that has. So you're not going to build a proper family using Rhino inside Revit. I would say a proper family, you're going to want to associate parameter, like use your label parameters to make these associations. On this geometry, we're associating the material with their parameter, because that's where you really get powerful, is like being able to create a proper family in Revit and then manipulate it with from a data-driven workflow, either in Dynamo or Grasshopper. So that's how this is done. So there's type or instance parameters that are driving those that we're modifying, and then we're also modifying the if you go back here, those are, I think they're instance based materials as well. So that's what's going on.
Okay, cool. And last question is, how can we bring unitized curtain wall panels built in Rhino into Revit as part of a curtain wall system, if possible?
Well, that's similar here. So unitized. So these, like, you'd want to have a curtain panel family. That's what these are right here. So you could bring in the geometry here. I have other examples, but it depends exactly what you're trying to do, which is going to be my answer to everything.
Yeah.
And I can qualify that. Because, all right, so are you looking to schedule each individual part? Then they're going to have to be like a nested shared family that you can actually access. Or are you just trying to dump the information in, dump the geometry in, maybe with a little bit of information that you could schedule or get quantities from and tag for coordination purposes? Or are you trying to build something more? So it's like, okay, is it just for coordination, or you're trying to do something a little bit more complex? You have options to do both, for sure.
So the answer is it depends.
Exactly.